Hey everyone! In this video, I'm going to show you how to use Packer to automatically build an AWS AMI, which we can later use in an auto-scaling group. First, let's quickly understand what Packer is. Packer is a tool by HashiCorp that allows you to create machine images in an automated way. In AWS, that means building a custom AMI with everything pre-installed, like NGINX, your app, or any dependencies. This is super useful for autoscaling because instead of configuring servers every time they launch, you just use a ready-made image. Now, I already have Packer installed on my Mac, and I also have a Packer configuration file ready. So the workflow is very simple, just 3 commands. Step 1, initialize Packer. This command downloads all required plugins. Packer init dot. Step 2, validate the configuration. This checks if there are any errors in your Packer file. Packer validate dot. If there are issues, fix them before moving forward. Step 3, build the image. This command actually creates the AMI in AWS. Packer build dot. To automate all of this, I created a simple bash script. The script runs init, validate, and build in order and stops immediately if any error occurs. Before running the script, make sure your AWS credentials are configured using the AWS CLI. Once the build is successful, Packer will output an AMI ID. You can then use that AMI in a launch template and connect it to an auto-scaling group. And that's it. Now you have a fully automated image build process. In the next video, we can connect this AMI to a full auto-scaling setup with load balancer.
Hey everyone! In this video, I'm going to show you how to create a VPC using the AWS Management Console. Here you'll see 2 options. We'll choose VPC and more, because this option automatically creates subnets, route tables, and gateways for us. Now let's configure it. Give your VPC a name, for example, My Project VPC. For the IPv4 seeder block, keep the default value, 10.0.0.0/16. Next, choose the number of availability zones. I'll select 2, so our setup is more reliable. Now for subnets, set 2 public subnets and 2 private subnets. Public subnets will be used for the load balancer, and private subnets will be used for EC2 instances inside the auto-scaling group. Next, scroll down to NAT gateways. Select 1 per AZ if you want a production-ready setup. This allows private instances to... We'll not just create a VPC, but a complete network setup.
Hey everyone! In this video, I'm going to show you how to create a launch template in AWS. First, go to the AWS console and search for EC2. Open the EC2 dashboard. Now, click on Create Launch Template. First, give your template a name. I'll name it my_NGINX_template. You can also add a description if you want. A launch template is basically a blueprint for EC2 instances. Instead of configuring servers manually every time, we define everything once, like the AMI, instance type, security group, and key pair, and autoscaling will automatically launch instances using this template. Next, under Amazon Machine Image, select the custom AMI we created earlier using Packer. This is important because every EC2 instance launched by autoscaling will now use this pre-configured AMI automatically. Now, choose an instance type. For this demo, I'll use t2.micro because it's included in the free tier. Next, select your key pair so you can SSH into the server later if needed. Now, scroll down to Network Settings. Choose the security group we created earlier inside our VPC. This security group allows HTTP and SSH traffic. For subnet selection, we usually leave it empty here because autoscaling will choose the subnets later. Now, scroll down to Advanced Details. Here you can add a user data script if needed, but since our AMI already contains everything from Packer, we can leave this empty. Now, review everything once. Click on Create Launch Template. And done! Our launch template is now ready. In the next step, we'll use this launch template inside an auto-scaling group so AWS can automatically create and manage EC2 instances for us.
Thanks for watching.
Hey everyone! Before creating the launch template, we first need to create our security groups. Security groups work like firewalls in AWS. They control which traffic is allowed into our resources. For this project, we're going to create two security groups, one for the load balancer and another for the auto-scaling EC2 instances. First, go to the AWS console and search for EC2. On the left side, click on Security Groups. Now click on Create Security Group. First, we'll create the Load Balancer security group. For the name, enter project-01-ALB-SG. Make sure to select the VPC we created earlier. Now, under Inbound Rules, click Add Rule. Select HTTP. And for source, choose Anywhere IPv4, which is 0.0.0.0.0/0. This allows users from the internet to access our load balancer. Now click Create Security Group. Perfect, our ALB security group is ready. Now let's create the second security group for the auto-scaling instances. Again, click Create Security Group. For the name, enter project-01-ASG-SG. This part is very important. Make sure to select the correct VPC. Now we need to add 3 inbound rules. For the first rule, type HTTP. But instead of allowing traffic from anywhere, we'll allow traffic only from the load balancer security group. So in the source section, choose Custom. Then select project-01-ALB-SG. This is very important because now only the load balancer can communicate with our EC2 instances on port 80. Now add the second inbound rule. Type HTTP. Source Anywhere IPv4, which is 0.0.0.0/0. And finally, add the third rule. Type SSH. For source, choose My IP. This allows only your system to connect through SSH securely. Now click Create Security Group. Great, both security groups are now ready. Now we can go back and continue creating the launch template. Inside the launch template network settings, select the security group, project-01-ASG-SG. This is important because every EC2 instance launched by autoscaling will use the security group automatically. And that's it. Now our launch template is properly connected with secure networking and load balancer access. Thanks for watching. Hey everyone! In this video, we're going to create our auto-scaling group. The auto-scaling group automatically launches and manages EC2 instances based on traffic and CPU usage. Earlier, we already created our VPC, security groups, a custom AMI using HashiCorp Packer, and a launch template. Now we'll connect everything together. First, go to the AWS console and search for EC2. On the left side, scroll down and click on Auto-Scaling Groups. Now click on Create Auto-Scaling Group. For the auto-scaling group name, enter project-01-auto-scaling group. Next, under Launch Template, select project-01-LT. This launch template already contains our custom Packer AMI and security group configuration. Now click Next. For the network section, select the VPC we created earlier. Then select the public subnets. For this demo setup, we're using public subnets. In production environments, auto-scaling instances are usually placed inside private subnets. Now click Next. Here, AWS asks about the load balancer. Right now, we are not creating the load balancer. We'll create it later separately. So choose No Load Balancer. Now, for health check grace period, set it to 30 seconds. Then click Next. Now configure the group size. Desired capacity, 1. Minimum capacity, 1. Maximum capacity, 5. This means AWS will always keep at least one EC2 instance running, and it can automatically scale up to 5 instances if traffic increases. Now scroll down to Scaling Policies. Choose Target Tracking Scaling Policy. Then select Average CPU Utilization. Set the target value to 50%. And for instance warm-up or cooldown, set 30 seconds.
This means whenever CPU usage goes above 50%, AWS can automatically launch more EC2 instances. Now, keep the rest as default. Click Next. Again, keep the defaults. Next, and next again. Finally, review everything once. Now click Create Autoscaling Group. And done. Our autoscaling group is now running. AWS can now automatically create or terminate EC2 instances based on CPU load. In the next step, we'll create an application load balancer and connect it with this autoscaling group. Thanks for watching.
Now our autoscaling group has successfully launched the EC2 instance. To verify everything is working correctly, go to the EC2 dashboard and click on Instances. Here we can see our instance is running. Now copy the public IPv4 address of the instance. Open a browser and paste the IP address. If everything is configured correctly, we should see our application or NGINX page running successfully. That means our launch template is working, our Packer AMI is working, and our autoscaling group is successfully launching EC2 instances automatically. And that's it. Our setup is working perfectly.
Hey everyone, now we're going to create our load balancer. Now click on Create Load Balancer. Here, AWS gives us 3 types of load balancers. For this project, we'll create an application load balancer. So click Create. Now, give the load balancer a name, Project 01-LB. Next, choose Internet Facing. This allows users from the internet to access our application. Now, select the VPC we created earlier. Next, select the availability zones and subnets. Choose the public subnets because the load balancer must be publicly accessible. Now, scroll down to security groups. Here, select Project 01-ALB-SG. This security group allows HTTP traffic from anywhere. Now, before creating the load balancer, we need to create a target group. So click Create Target Group. This opens a new page. For target type, select Instances. Now give the target group a name, Project 01-TG. Select the same VPC. Keep the rest as default. Now click Next. Here we can manually select instances. Choose the running EC2 instance and click Include as pending below. This is just for testing. In real production setups, autoscaling usually attaches instances automatically. Now click Create Target Group. Perfect. Our target group is now created successfully. Now go back to the Load Balancer tab. Refresh the target group section. Now select Project 01-TG. Keep the rest as default. Now click Create Load Balancer. AWS will now start provisioning the load balancer. This may take a little bit of time. Once the status becomes active,
All right, now we have one final important step. We need to connect our autoscaling group with the load balancer target group. Go to the AWS console and open Autoscaling Groups. Now select Project 01 Autoscaling Group. Next, open the Integrations tab. Here you'll see the Load Balancer section. Click Edit. Now select Application, Network, or Gateway Load Balancer Target Groups. Under Target Groups, choose Project 01-TG. This is the target group we created earlier and attached to our application load balancer. Now click Update. And done. Our autoscaling group is now fully connected with the load balancer. This means whenever autoscaling launches new EC2 instances, AWS will automatically register them inside the target group. And the load balancer will distribute traffic across all healthy instances automatically. Now our complete architecture is working together. Load balancer, target group, autoscaling group, launch template, and the custom AMI created using HashiCorp Packer. And that's it. Our AWS autoscaling infrastructure setup is fully complete.
copy the DNS name of the load balancer and open it in your browser. If everything is configured correctly, our application should now be accessible through the load balancer successfully. And that's it. Our application load balancer setup is complete.
All right, now let's connect to our EC2 instance and see how autoscaling reacts under heavy CPU load. Go to the EC2 dashboard and copy the public IP address of the running instance. Now open your terminal. We're going to use two separate terminal tabs. In the first tab, SSH into the instance using your key pair. Run ssh-i yourkey.pem ubuntu at your public IP. Once connected, in the first tab, run top. This command lets us monitor CPU and memory usage in real time. Now open a second terminal tab and SSH into the same instance again. We use two tabs because one tab monitors the server using top, and the second tab generates stress on the server. Now, inside the second tab, install the stress tool if needed. Run sudo apt update. Then sudo apt install stress y. Now we'll generate CPU load. Run stress-c4. This command starts stressing 4 CPU workers continuously. Now go back to the first terminal tab where top is running. You'll notice the CPU usage becoming very high. As CPU usage crosses our auto-scaling policy threshold, AWS will automatically start launching a new EC2 instance. After a little time, go back to the auto-scaling group or EC2 dashboard. You should now see another instance launching automatically. That means our auto-scaling setup is working successfully under real server load.
All right, now we can see that autoscaling has successfully launched multiple EC2 instances. Earlier, we started with just one instance. Then we generated heavy CPU load using the stress command. As the CPU usage crossed our scaling threshold, AWS automatically started creating new EC2 instances. And now we can see the auto-scaling group scaling all the way up to 5 instances automatically. So let's quickly recap everything we did in this project. First, we created a custom AMI using HashiCorp Packer. Then we created our VPC, public and private subnets, route tables, and security groups. After that, we created a launch template using the custom Packer AMI. Next, we created an auto-scaling group with dynamic scaling policies based on CPU utilization. Then we created an application load balancer and target group. Finally, we connected the auto-scaling group with the load balancer target group. To test the setup, we SSH'd into the EC2 instance, monitored the server using the top command, and generated CPU stress using the stress tool. As traffic and CPU usage increased, AWS automatically launched additional instances. This demonstrates how auto-scaling helps applications stay highly available and automatically handle increased traffic. And that's it. We successfully built a fully automated AWS infrastructure with Packer, custom AMIs, launch templates, auto-scaling, and load balancing. Thanks for watching, and I'll see you in the next project.